Are you interested in new world-changing technologies, implemented without fear or greed, open sourced? If so, you're in the right spot, because that's what we're doing from here in my garage. We're following our passion, our dreams. We're releasing a new clean energy technology for the people, open sourced. And I'm gonna bring you along for the ride every step of the way. The last 15 years of my life has been devoted to this mission. I've researched patents, suppressed technology, built prototypes, got an electrical engineering degree. I've done everything in my power to get to this spot where I'm ready to go after this tech and bring it forward to the people. There's an abundance of technology just waiting for us. There's oceans of energy all around us, ready for us to take in and utilize from the environment. So for anybody new here, the way we're going about this new clean energy technology is we're utilizing magnets and wire. So just a quick high level of what happens when you have a coil of wire, such as this one here, just basic wire, and you put electricity through it. So let's say we put a electrical current going from positive to negative here. So we've got electrical current going through this coil. We're gonna induce a magnetic field, say north down here, south up there, to be induced. Now, if we switch the direction of the current flow or the electricity, if we put the electricity coming in from that end and traveling up to this end, so now the opposite of this coil here, we've got the electricity flowing the opposite way, what's going to happen? We're going to have the magnetic field also go in the opposite direction from previous. So just get that in your heads, that basically electricity flowing one way in a coil produces a magnetic field. Flowing in the opposite direction, it produces the magnetic field in the opposite direction. So why is this important in our society? This principle is how we generate electricity. It's also how we produce electric motors in all of our society. It's just coils of wire and magnets. If we want to produce a motor, we're going to put electricity through a coil, and it's going to cause a magnetic field to be induced in the coil, and that magnetic field's either going to attract or repel magnets. If you have those magnets on a rotor, such as this, then it'll cause a rotational motion. So that's how an electric motor works. Generators, whether it's in a hydroelectric dam or in a wind turbine, they work on the same principles, just backwards. We're taking moving magnets and inducing a magnetic field and electric current into the coil. And then we're taking that electricity and using it for power. That is what powers our society. And this basic principle is also what we're utilizing in this machine here, in this new technology that we're bringing forth, this new clean energy technology. The only difference here is that instead of a constant flow of electricity, we're doing a pulse. So we're putting an instantaneous pulse into this coil as the magnet comes by, and it causes a magnetic field to be induced, and then that makes this rotor spin. Now, that's not all we're doing here. Once a magnetic field has been induced into a coil and you shut off that electricity that's causing the magnetic field, there's a collapse of it. So that can be thought of as taking a garden hose and, say, filling up a balloon. You're pressurizing it, and when you take the garden hose out of the balloon, it's going to spray out with more force than what was in the garden hose initially. Or if you just allow a garden hose to pressurize up and then you release the handle on it and it sprays out with more force than what was actually. That's sort of an analogy for this. Not quite complete, but it's a good way of thinking of electricity, that the voltage is a pressure, the amperage is a flow. So when we pressurize this coil with electricity and then we shut off, that pressurization wants to flow backwards. There's a backflow of energy coming out of these coils. So we pressurize the coil, shut it off, there's a backflow of energy. That flyback voltage is at a much higher pressure than the initial voltage that we used to energize the coil. So on this system, we're putting in 12 volts, and the collapse of this magnetic field, the flyback voltage, is in the hundreds of volts. Now, when this field collapses, we're taking that energy and we're recycling it. So we're putting it into another battery. So we have two battery banks. One is to power the system. One is to recycle the energy. How are we getting excess energy from this? Well, when we put a high voltage spike into a lead acid battery, there's something magical that happens, and it causes an instantaneous opening of a dipole that allows us to collect excess energy from the vacuum, space, 0 point energy. Basically, there's an ocean of energy all around us, whether you're in the vacuum of space here on Earth, underwater, anywhere. All space has energy within it, and it's available for us to tap into and utilize. So we're not breaking laws of thermodynamics, we're just simply tapping into an existing ocean of energy from the environment and utilizing it. It's no different than solar power. It's an ocean of energy available for us to utilize. Now, going from this is a precursor prototype to what we're doing over here. This is our large version. This is the current project that we're working on. It's a old type of motor that uses switches called transistors. So these are the electronics. The transistor is a type of switch. This new version is a souped up version of that motor. So it's higher voltages, bigger amounts of batteries, and larger coils, different types of switching components. So we're not using transistors, we're using MOSFETs, another type of an electrical switch. But the MOSFETs are much more efficient. They switch quicker. They are silicon carbide components. All of the components that we're utilizing in this circuitry in this motor are silicon carbide because of the very fast, instantaneous switching ability of it. So this motor we've been building for 6 months or so now. It's starting to come together. We've got the rotor moving. We've got 16 magnets embedded in this rotor. You can see they are epoxied in, and the slots in which they go are tapered so that they cannot come out of the rotor when it's moving at high speeds. So these magnets are permanently embedded in the rotor. We've got the rotor spinning. We've got a few upgrades to do. I'm going to actually take these strips of acrylic and mount it as ribs on the back of this piece here, just because there's a bit of wobble in it. I didn't expect that to be quite so wobbly, or movable I should say. So anyways, I'm going to put some ribs along here of this material. That's also going to allow me for some spots to mount the photo sensors when I have this trigger wheel on. So we can mount a photo sensor somewhere along here, and it'll optically, an optic sensor I should say, and it'll optically allow this trigger wheel to trigger the pulses and the electronics as the magnets go by. So what have we been working on since you guys last tuned in? Well, I'm going to show you some footage here of me winding this coil. So now we are in some soccer fields that are near my house, and I'm setting up a little tower initially here. This tower is going to be used to keep the wire off of the ground halfway down the length of it when I'm twisting it together, just because it sags so much it touches the ground and I don't want to get grass in it. Now you can see me walking out lengths of wire from the spool, 250 feet in length, and I do this back and forth, 8 times per coil. We wound enough for 2 coils this day, so that was 2 hours or so spent in this field plus setup time. And now we're going to go on to the final length of wire here, and we're walking down to the end where we are going to combine all 8 wires onto the end of the drill here, which has a hook, and I'm starting to twist them together. And you can see it snaps there. So luckily I had my hand on the wire, because if you let go of it, when it does that, it'll kink up and destroy the whole build. Luckily I didn't do that. Now that I've got them twisted together, I'm doing a final inspection down the line, just taking a look, making sure that it's equally twisted in all the sections. And you can see the tower here did its job of keeping the wire suspended off the ground, preventing any kind of grass getting caught in it. These are the temporary coils that we're now going to spool the wire onto. I've got some cloth on there to protect the wire and give it a little bit bigger circumference so it doesn't bend too much. And I'm going to get it started and then use the drill to spool this onto the temporary coil. This is almost the home stretch. I feel a lot better. There's not really much that can go wrong here. You can't really screw too much up. You can certainly mess a lot of stuff up when you're twisting them together. Like I say, kinks are detrimental. I don't want any kinks in this wire. So you can see the sun is setting. We've been out here for a couple hours. We're going to get this wire on there, and now we're back in the shop. And I'm showing you that I've got the coil core in between 2 channel aluminum pieces there, and I've sandwiched it together with some ready rod and nuts. And this setup is not only going to keep the coil core nice and tight and won't allow it to bow outwards, but it's going to allow us to put it into this makeshift lathe that I've set up, and we're going to utilize my drill to spool it on. Right now I'm feeding the wire through a hole in the side of the coil and channel aluminum. I'm going to pull enough through that we have a couple feet in length on either end, and then I'm going to neatly ravel it up and tape it. You can see it there, it's taped up so I can spin up the coil. I've also got tape in the hole between the channel iron and the coil itself, just so it doesn't rub through. That would be another detrimental thing that can happen if you rub off the coating of the wire and the wires touch and short out. That's basically messed up all your hours of work. And now I'm starting to spool on the wire onto the coil. It's slow going initially, and then once you get a few layers down, it starts to go a bit quicker, but nevertheless, this took another hour and a half or so per
coil, and I'm getting close to the end here. We're going to look for the epoxy. We're going to start coating this in epoxy as soon as we can, as soon as we get it finished. You can see it's looking pretty nice here. I'm happy with how this one turned out, and I'm going to start mixing up the epoxy so we can glue this all together and get it set up before anything comes apart. And this is the mixing of the epoxy. I'm just going to coat it on there with my gloves, spread it evenly over the coils, and get it attached to the coil core. So I hope you guys enjoy this building behind the scenes, and we're going to cut back to the rest of the video.
I hope you guys enjoy the behind the scenes. It was a lot of work. It took me 8 hours basically to produce these first 2 coils. It'll get more efficient and better. I'm gonna put a foot pedal on my little makeshift lathe there, so it'll allow me to wind it easier. It really took a beating on my hands. My forearms are still sore from trying to pull that wire out. Anyways, enough whining. The coils look amazing. I'm super happy with it. I'm just going to keep epoxying this one, and yeah, we're going to have to build a bunch more, but this gives us enough to get this thing running. And I'm going to get this one mounted, and then the next step is Joe's Electronics. So my good friend Joe Mullen, I met him after the first video I made. He reached out from Ontario. The guy's super genius, loves building electronics, especially silicon carbide components. So it was literally a match made in heaven. It's like the universe aligns when you follow your passion in life and take action without knowing the path and just the end goal. So that is amazing. A note on that, our end goal on this technology is to prove that it is real and implement it. So even if this particular machine is 1 watt over unity, 10 watts over unity, 100 watts over unity, it doesn't matter how much electricity it actually produces in excess. The fact that we can prove it and replicate it is world changing. So that's our goal, at least the initial goal right now. Once we get that figured out, then scaling this and getting it so it can power homes and power our society is the next goal. Going after other technologies such as Crom ray converter or Brown's gas are also on my list to do, but one step at a time. So Joe and I are both very passionate about this, and I would like to show you some of his electronics. He's basically got the boards out for manufacture right now, and he's going to be putting the electronics on it. And yeah, we should have that by the next video. I'm hoping to have at the very least the coils mounted and some of the electronics coming in, but I need funding at this point. A lot of you have been reaching out. A lot of you are offering money already, and even if there's 1,000 of us that only put in, say, $10, $20, I mean, that's enough to fund the project. Hopefully some of you will put in hundreds of dollars, some just put in what you can, but I need help with this project. This scientific endeavor costs money. I've already funded over $10,000 myself on my own. Joe's donating his time. We both work for free. I mean, just these coils alone took me 8 hours. I have to work a full-time job as well. I would eventually like to do this full-time, but for now I have to pay the bills elsewhere. The batteries alone are going to take roughly $5,000. The electronics are another $5,000 to $10,000. I'm going to set up a crowdfund for a $20,000 goal on Indiegogo. I'm going to put a link in the next video by the end of July where you guys can pitch on that and we can truly show the world what's possible when we work together. I know how amazing it's going to feel when you see this working and implemented and you know that you believed in it along with myself before the final proof was there. You have to believe in order to dream and in order to go after it. So that's what this channel is about, is knowing that there's limitless potential in all of our technologies, in ourselves. We need to dream big. Big dreams are what this channel is about, and I know that working together with the right intention, we can get this technology out to where it's supposed to be. The problems that we're experiencing right now in this world were not necessarily created by us, but they have to be solved by us. We are the ones that have to solve them, even if we didn't create them. It's good. Like, problems are a good thing, right? You don't get gains without pain. You have to know what you don't want in order to know what you do want. So we don't want the current top-down controlled energy distribution in our society. We don't want suppressed technology. We want our technology to come out and be utilized for the good of the planet, for the good of humanity, for the good of all of us, with the common goal of making this reality better for ourselves and future generations. So that's what we're about. That's what we're going to do with the next video and the crowdfund. I just want to say I love you guys so much. This is incredible. I can't believe the last video got 65,000 views or something insane. And I love the comments. It's overwhelmingly positive. A lot of time for me to respond to them, but that is me responding. I'm responding to, it was like 1,000 comments in a week. I love to see it. People are reaching out. I'm going to get a domain set up and like a separate email for this, because honestly I'm getting like 3 or 4 emails a day, and and they get scattered. And I'm gonna get a separate domain set up by the next video, the crowdfund set up. We're gonna get Patreon, Cash App links. Crypto, if you're into that, is welcome. Huge shout out to Kyle. We're working together to bring you guys this technology. I'm sure we're gonna find others along this journey that wanna help, and I love hearing your comments. I had a guy reach out from Alberta. I'm gonna end the video with this. I'm gonna show you his device that he sent me, a beautiful Bedini build. I'm half dyslexic, you guys, so I know the words that I'm trying to say, sometimes they don't come out correctly. Thank you for correcting me on the last video. Bedini, not Bendini, Bedini. Honestly, I've been saying it that way. I remember my buddy in university like 10 years ago telling me that. He's like, it's Bedini, not Bendini. I'm like, yeah. I'm like, I know what I'm saying. Anyways, so I'm half dyslexic, bear with me. This guy from Alberta, Ryan, he sent me a video of his build, his Bedini build. Amazing, looks incredible. It's an iron core transistor version, but I wanna show you the video footage here just for a second. Look at it, it looks amazing. So cool, Ryan. Thanks for your shout out. I look forward to meeting you when you come to BC. There's a lot of people building these machines. Me and Joe see the same thing though. This is what Paul Babcock talked about, is they're still being built at low voltages with iron cores. We got to stop that. If you want to get the excess energy, we got to step up the voltages, step up the frequency. Silicon carbide components, N-channel MOSFETs. Joe and I in the future will do a video very soon where we go through Joe's design on his circuit board. He can explain every little component, why it's there, what it's doing, and then that should put an end to the need for people to use the transistors, right? We don't have to use John's circuitry anymore. We can move forward to the future where we're in now compared to where John was. So anyways, very exciting. I love you all. I can't wait to put another video. It's probably gonna take me 10 days to 2 weeks to put out the next one. And I promise I'm gonna have the crowdfund set up so we can combine our energy to make this scientific dream a reality and change the world.